Okay, so today's lesson is going to be on an introduction to chemical calculations. All right, and we're going to start with a flow chart, which we're going to copy down, and then we're going to try and come back and make the flow chart make sense. So I could go from grams to moles, where the mass of the substance from the periodic table will equal 1 mole. What is a mole? A mole is simply a measurement. All right, so it tells us how much of something there is. For example, a dozen eggs. How many eggs is in a dozen? 12. All right, so that's what the mole is. It tells us the quantity of something. From the mole, I could go to formula units. If the compound is ionic, or molecules if the formula is covalent. So it's going to be important to know what an ionic and a covalent compound are. Covalent contain nonmetals, ionic contain a metal with a nonmetal or a polyatomic ion. All right. So some examples of formula units, and we're going to just abbreviate that FUN, F-U-N, formula unit. MgF2, let's see, sodium acetate, NaC2H3O2, MnO2. These are all examples of formula units, ionic compounds. Some examples of covalent compounds, we're going to abbreviate that MOLC, put a C there for molecule, because if you leave the C off, you write the word mole. All right, MOL is the abbreviation for mole. All right, BF3, CH4, and SO2. These are all examples of molecules containing only nonmetals. Now, what is our conversion factor? 1 mole is going to equal 6.022 times 10 to the 23rd formula units or molecules. So that's going to be a formula unit or a molecule. And this value, 6.022 times 10 to the 23rd, is called Avogadro's number. All right, named after the scientist who discovered this. Now, from here, we could go to ions. If it is ionic compounds contain ions. Or we could go to atoms, and we could go to atoms in both an ionic and a covalent compound. And our conversion factor here is going to be 1 formula unit will equal the number of ions or atoms if it is a covalent compound. 1 molecule will equal the number of atoms. So here's our flow chart. Let's do some practice and see if we can't make this flow chart make some sense. So now we're going to be on our Introduction to Chemical Calculation example worksheet. Step 1, we're going to fill in this chart because we're going to use this chart to answer some questions. So let's do some practice. CO2, formula unit or molecule. It contains only nonmetals, so it is a molecule. How many atoms are in this compound? I have 2 oxygens and 1 carbon. So I have 3 total atoms. 2 of them are oxygen and 1 of them is carbon. How many ions? None. It is a molecule. It does not have ions. And what is my molar mass? CO2 is going to be 12.01 plus 16 times 2 is 44.01. So what I'd like for you to do, I would like for you to pause this video and then come back and check your work after you have filled in this table. All right, so let's check our work. Rubidium nitrate is a formula unit. It has a polyatomic ion. How many atoms? It has 1 rubidium. It has 1 nitrogen. And it has 3 oxygens. So 3 plus 1 plus 1 gives me a total of 5 atoms. How many ions? Rb plus and NO3 minus. That is 1, 2 ions. And my mass is 147.48. F2 is covalent. It is a molecule. There are 2 fluorines. It does not make ions. And the mass would be 38. And again, molar mass is 2 decimal places. So we're just going to make that a 0.00. P2O5. This is a molecule. It has only nonmetals. I have 2 phosphorus. And I have 5 oxygens for a total of 7 atoms. Again, molecules don't form ions, and the molar mass is 141.94. If you need help with how to determine this molar mass, please go watch my video on determining molar mass. All right, this guy has polyatomic ions, so it is a formula unit. It is fun. All right, how many atoms? 1 nitrogen times 2 is 2. 2 nitrogens. 4 times 2 is 8 hydrogens. I have 1 sulfur. And I have 4 oxygens. So how many total atoms do I have? 8 plus 2 is 10, plus 4 is 14, plus 1 is 15. How many ions? I have 2 NH4s, plus 1 sulfate. That is 3 ions total. And the molar mass is 132.17. Sodium chloride is a metal with a nonmetal, so formula unit. I have 2 atoms. I have 2 ions, Na plus and Cl minus. And the mass is 58.44. So now let's use our flow chart and let's do some practice. And this is where our metric system that I taught you guys how to solve, and I said we're not going to do a decimal place. I need you to learn the process. This is why I asked you to learn that process, because we're going to use that same process we used in the metric system in order to solve these problems. All right, how many moles are in 2.50 grams of carbon dioxide? So I have 2.50 grams of carbon dioxide. Now let's review. The unit on top goes on bottom. So if gram is on top, it goes on bottom. Now, where can I go in my flow chart? The only place the gram can go is to the mole, where 1 mole is the mass from the periodic table. So we're going to set up our units first and then go back and add in our numbers. 1 mole is the mass of carbon dioxide from the periodic table, which we found to be 44.01. That is the molar mass. Molar mass. And when we solve for that in our calculator, we get 0.0568 grams of carbon dioxide. Units with the label, my friends, tell me what that value means. Notice I have 3 significant figures, so my answer has 3 significant figures. Make sure your final answer is to correct sig figs. All right, how many grams are in 0.732 moles of carbon dioxide? So in this case, I have the mole. So if mole is on top, it goes on bottom, and I'm being asked for grams. From the mole, I am able to go backwards to grams, where 1 mole is the mass from the periodic table. So 1 mole is the mass of carbon dioxide from the periodic table, which is 44.01. And so that is going to give us 2.2 moles. I'm sorry, math. Okay. 32.2 grams of carbon dioxide. Now I need to come back up here to number 1. I put in the wrong unit. All right, I put 0.0568 and I erased the gram. That is the mole. Let's fix that. I went to moles, and this is where canceling out our units comes in handy. I was left with moles. If I had actually gone through and canceled my units, I would have noticed I wrote the wrong unit to begin with. How many molecules are in 3.45 times 10 to the 24th moles of fluorine gas? So if mole is on top, it goes on bottom. Now, I'm asked for molecules. So I'm going to go to my flow chart. I am at the mole, and I'm asked for molecules. This is a single step. Here's my flow chart. So I'm going to go to the molecule. Let me leave myself some space because I know that value is larger. Where 1 mole is Avogadro's number, 6.022 times 10 to the 23rd. So 1 goes with my mole, and Avogadro's number, 6.022 times 10 to the 23rd, goes up top. So when I plug this into my calculator, 3 significant figures. So I'm going to have 3 sig figs at the end, and that's going to be 2.08 times 10 to the 48th molecules of fluorine. All right, what is the mass of 7.5 times 10 to the 23rd molecules of CO2? If molecule is on top, it is going to go on bottom. Now, I am at the molecule, and I am being asked for the mass. So I'm going to have to go to the mole and then to the mass. All right, so this is a 1-2 step problem. So I'm going to go to the mole first, where 1 mole is 6.022 times 10 to the 23rd. Now, if mole is on top, mole has to go on bottom. And coming back to my flow chart here, mole can go to the gram, where 1 mole is the mass from the periodic table, and I found the mass of carbon dioxide to be 44.01. And we'll cancel out our units. Molecule is on top and bottom. Mole is on top and bottom, and I am left with grams, which is mass, so that's good. Now, that's going to give me 5,481 grams. I have 2 significant figures, so you need to put this into significant figures. You can either put it into scientific notation, 5.5 times 10 to the 3rd, or you can write it as 5500 grams. Either one of these would be an appropriate answer. All right, let me fold this paper a bit so we can see our chart above. Okay, and let us determine the number of atoms in 3.22 formula units of ammonium sulfate. I have 3.2 times 10 to the 22nd formula units of ammonium sulfate. All right, if formula unit is on top, formula unit has to go on bottom. So where am I at my flow chart? I am here, and I am asked for the number of atoms right here. So I'm going to do one formula unit equals the atoms. I can do a single conversion to atoms, where one formula unit is the number of atoms, and we determine the total number of atoms in this compound is 15. I could have asked you how many atoms of nitrogen. In that case, you would have put a 2 here. Okay, so it really just depends on what you're asking for. When I plug this in, I find a value of 4.8 times 10 to the 23rd atoms. So what I would like for you to do is pause this video, try these remaining 4 problems, then come back and check your work. All right, so let's check our work. I have 3.2 times 10 to the 23rd units, formula units of ammonium sulfate. All right, and I've been asked for the number of ions. So if formula unit is on top, it has to go on bottom. And here's my flow chart. My formula unit can go to ions as well, where one formula unit is the number of ions. So one formula unit, how many ions in ammonium sulfate? We found that ammonium sulfate has 3 ions. So when I plug this into my calculator, I get 9.6 times 10 to the 22nd ions. All right, how many ions of ammonium are in this same value? So notice we're using the same value here, and we're kind of working out a bunch of different types of ways to go. Formula unit is on top. Formula unit funds, where formula unit is on bottom. All right. And I want the ions of ammonium. So I'm still going, one formula unit is the number of ions. So I'm still in the same section here. And I'm being asked for ions of ammonium. So ammonium would be NH4 plus. So my formula unit is the entire compound. So that would be NH4, 2, SO4. And I'm looking for the ions of ammonium. So one formula unit we determined has how many ions of ammonium? There are 2 ions of ammonium. All right, so when I plug that into my calculator, I get a value of 6.4 times 10 to the 22nd ions of ammonium. Determine the number of moles in 7.98. So what we start with here, atoms of sodium chloride. If atoms is on top, it goes on bottom. Now, Looking at my flow chart here, the only place to go from atoms backwards is to the formula unit if it is ionic, molecule if it is covalent. Sodium chloride is an ionic compound, so we are going to go to the formula units. Where one formula unit is the number of atoms. One formula unit is the number of atoms, and there are 2 atoms in this compound. Notice I'm setting up my units first and then plugging in my numbers, just like we did for our metric. Units first. So if formula unit is on top, I have to put it on bottom because I want the moles. So formula unit, I'm going back to the mole. So I can go from formula units to the mole, where my flow chart tells me 1 mole is 6.022 times 10 to the 23rd formula units. So here we go. When we plug this into our calculator, you should get a value of 6.63 moles of sodium chloride. Okay, let's do one more. What is the mass in 2.3 times 10 to the 24th atoms of diphosphorus pentoxide? If atoms of diphosphorus pentoxide is on top, that goes on bottom. Now, if I am at the atom, the only place I can go is the formula unit for an ionic or the molecule for a covalent. Diphosphorus pentoxide is a molecule. And my flow chart tells me 1 molecule is the number of atoms. So 1 molecule is the number of atoms. And we determined that diphosphorus pentoxide has 7 atoms. Now, I want the mass. I am at the molecule, so I have to put the molecule on the bottom. And from the molecule, my flow chart tells me I have to go to the mole. So I'm going to go to the mole, where 1 mole is Avogadro's number. 1 mole is Avogadro's number, 6.022 times 10 to the 23rd. Again, I am looking for mass. I am at the mole. So I have to do one more step. If mole is on top, it goes on bottom. And from the mole, I can go to the mass using my flow chart. 1 mole is the mass from the periodic table. So 1 mole is the mass, and the mass of diphosphorus pentoxide we determined to be 141.94. So when I plug this entire thing into my calculator, I find that I have a mass of 77.4 grams.